Good morning to everybody here. Hello. Good morning to everybody. Now, this is UG 5th semester mathematics, elective A 3-dimensional geometry paper. Okay. Now, once again, good morning to everyone. Now, this is one of the important session. Okay. This is one of the important session of 3-dimensional geometry. Already we have discussed in the previous classes. Okay. What is the plane, general form of a plane and the normal plane and angle between the two planes and the intersection of the two planes? Some other problems are also practiced. Okay. Please stay on the line. Let us, we have discussed some other problems in the plane and skew lines and straight lines problems. Okay. Please stay on the line. Students, listen carefully. Now, already you have discussed in the previous class, in the last class, angle between the two planes and any 3 points is given. How to find the plane equation? Through the 3 points, how to find the plane equation? Now, let us see the one more important problem here. Okay, already we have discussed the perpendicular distance from the perpendicular distance from the origin to the plane and from the point to the plane. Okay, now these problems are also yesterday class are also to be practiced here. To practice here. Okay. Okay, already intersect form of a plane equation, that is also one of the important theorem in the final examination. Okay, and their problems are also practiced. Okay. See this one. What is the intersection of any two planes? Now that formula is S1 plus lambda S2 equal to 0, either P1 plus lambda P2 equal to 0. Okay. Now that is one of the important concept in between the planes. The intersection of any two planes is S1 plus lambda S2 equal to 0. Okay. Now here already this problem is also practiced. See this one 2.6.2. This problem is very important in the final examination. Students, listen carefully. Okay. What is that? Find the equation of the plane passing through the points 2, 2, 1. This is the one of the point, and second point is 9, 3, 6. This is the second point. And these points and perpendicular to the plane 2x plus 6y plus 6z equal to 9. Now, here 2 points is given. These points passing through the passing through the plane, and at the same time this is also perpendicular. These points are when the passing through the points perpendicular to the plane is 2x plus 6y plus 6z equal to 9. Now how to form the plane equation? Okay, one plane equation is given. That plane equation of the perpendicular part in between the 2 points when the passing through the points to the plane, here 2, 2, 1 and 9, 3, 6. Now this problem is also number of times is given in the final examination. Okay, now what is the solution? Listen carefully. Here any plane passes through 2, 2, 1 is there. Okay, any plane passes through 2, 2, 1 is a of x minus 2 plus b of y minus 2 plus c of z minus 1 equal to 0. Okay, now this is one of the point is given, a of x minus 2 plus b of y minus 2 plus c of z minus 1 equal to 0. Say this is the first equation. When the first equation passes through and remaining the point, second point is 9, 3, 6. Now this point is say x1, y1, z1. In the replacing of x, y, z in first equation, we are getting the a of x means 9, y means 3 and z means 6 is there. That is a of 9 minus 2 plus b of 3 minus 2 plus c of 6 minus 1 equal to 0. Okay. See this one. Please stay on the line. Now, after the simplification, we are getting 7a plus b plus 5c equal to 0. See this one. Now that is 7a plus b plus 5c equal to 0. After the simplification, say this is the second equation. Now the plane first equation is perpendicular to the given plane. Now here the given the plane is 2x plus 6y plus 6z equal to 9. If here the normals are perpendicular to the given plane, means here the normals of in the replacing of xyz by ABC. So here the normals are 2, 6, 6 given the plane of the normals, means that is the drs 2, 6, 6. Now these normals are converting into the in terms of ABC, 2a plus 6b plus 6c equal to 0. Say this is the third equation. So here solving the equation, second and the third equation, these two equations are solving through by cross multiplication rule, that is CMR. Okay. Now these two equations, see and observe these second equation and third equation in terms of ABC. So in the second equation of the ABC normals, to write as B coefficient, that is 1, 5, 7, 1. And again to write the we are taking the another normals to write in the from the beginning of B coefficient 6, 6, 2, 6. Okay. Now after the simplification, we are getting the A value is 6 into 6, 36. Okay, 6, 6 to 6, and again this is 6, 6 to 6 is there. After the simplification, we are getting A by 6 into 1, 6 minus, that is also 30, A by 6 minus 30, B by 10 minus 42, C by 42 minus 2 is there. Okay. Students, listen this one. How to write the simplification. Okay. Please see here. CMR. Okay. Cross multiplication rule. Say this one. First of all, here the equation is 7a plus b plus 5c equal to 0. To write as the a, b, c coefficients from the beginning of the coefficient b. First of all, see if we get the if we are getting the value of a, to write as the b coefficient, that is 1, 5, 7, 1. And another one to see and observe the third equation, to write as the coefficient b coefficient, that is 6, 6, 2, 6. Now here the values of a by AD minus BC expression. 1 6 are 6, 5 6 are 30. That is the A value. B by 10 minus 42, C by 42 minus 2. Okay. Finally, we are getting A by minus 24 and B by 10 minus 42 means minus 32. That is C by 42 minus 2 means 40. So finally, A by, after the cancellation, the 8 minus 8 is there. Cancellation by minus 8, A by 3, B by 4, C by minus 5. Okay. Now cancelling by 8 and minus is also common is there. So that values are A value is 3, B value is 4, C value is minus 5. These values substituting in first equation. That is, what is the first equation? A of x minus 2. That is 3 of x minus 2 plus B value is 4 of y minus 2 plus C value is minus 5 of z minus 1 equal to 0. After the simplification, 3x plus 4y minus 5z minus 6 minus 8 and plus 5. Okay. Finally, 3x plus 4y minus 5z minus 6 minus 8 means minus 14 plus 5. That is minus 9 equal to 0. Finally, 3x plus 4y minus 5z equal to 9. See this one. This is the, see this one. Okay. Now that is the by CMR means cross multiplication rule. How to get the cross multiplication rule in between the second equation and the third equation? To write as this one is there. Students, listen carefully. Okay. Now, that is the required equation. Next one, that is, see this one, 2.6.3. This is also one of the important problem. Find the equation of the plane which passes through the point 3 minus 3, 1. Now, the above problem is points is given, that is also passing through the points and it is also perpendicular to the plane. How to form the plane equation? That is the above problem. Now, this problem is particularly when the passes through the point 3 minus 3, 1 and it is parallel to the plane. That is 2x plus 3y plus 5z plus 6 equal to 0. So, any plane parallel to the given plane is, already here the given the plane is 2x plus 3y plus 3z plus 6 equal to 0. What is the parallel equation? So, the distance is you have to take in the unknown value 2x plus 3y plus 5z plus k equal to 0. That k or lambda, whatever it is, according to the given plane, to write as the parallel part. What is the parallel part? 2x plus 3y plus 5z plus lambda equal to 0. This is the parallel to, for the given the plane. And say this is the first equation. When the first equation passes through, given the point is 3 minus 3, 1. So this is x, y, z, replacing of x, y, z. This is given the point is substituting in the first equation. We are getting the lambda value. What is the lambda value? That is minus 2. So substituting means 2 into x value is 3 plus 3 into y is minus 3. And again we are taking the plus 5 of z value is 1. So after the simplification, lambda equal to minus 2, that value substituting in the first equation, that is the required parallel plane equation. 2x plus 3y plus 5z, lambda is minus 2 equal to 0. Now this is one of the important problem. And again 2.6.4, find the equation of the plane which passes through the point and it is perpendicular to the plane. There are two planes is given and one point is given. The first point passes through the point, plane passes through the point and it is perpendicular to the planes 7x plus y plus 2z equal to 6 and 3x plus 5y minus 6z equal to 8. Any plane passing through the point, already one point is given. So what is the equation? A of x minus x1 means x1 means 3, y1 means minus 3. That is minus of minus 3 means plus 3 is there. Just you have to see here, see and observe. Okay, say this one. Y minus of minus 3 means y plus 3 plus c of z minus z1 means z1 equal to 1 equal to 0. So point is given. What is the plane equation? A of x minus x1 plus b of y minus y1 plus c of z minus z1 equal to 0. Say that is the first equation. So already perpendicular to the planes means given according to the normals 7, 1, 2, that is the first plane, and second plane of the normals 3, 5, minus 6. Those normals A1, B1, C1, A2, B2, C2 to write the normals of the part 7A plus B plus 2C equal to 0 because perpendicular means when the distance is 0, and again 3A plus 3A plus, okay, 5B, 3A plus 5B minus 6C equal to 0. Say that is the second and third equation, and solving the second and third equation through by CMR formula. CMR means cross multiplication rule. So to write the ABC coefficients from the beginning of B, see and observe the second equation to write the from the beginning of B coefficient 1, 2, 7, 1. And again to write the B coefficient in the third equation 5, minus 6, 3, 5. After the determinant of the from the above coefficients, we are getting the A by. So this is 1 into minus 6, and minus 10. And next B value is again 2. Okay. And again this value is minus 6. Okay. B value is 2 into 3, 6, minus 7 into minus 6, minus of minus 42 and plus 42, plus equal to C by and remaining coefficients. Okay. What is that? 7 5s are 35 minus 3. Okay. Finally, we are getting the values A by minus 16, B by 48, C by 32. After the simplification, minus 16 is cancelled and getting the values. So that is A value is 1, B value is minus 3 times, and C value is minus 2 times. Okay. Now those values substituting in the first equation, we are getting the required plane. So that is A value 1, B value minus 3, C value minus 2. That value substituting in the first equation of this part. This is the first equation. Say this is the first equation. Okay. Okay. Now that is the A, B, C values 1, minus 3, minus 2. We are taking the first equation. We are getting the values are, see this one. 1 of x minus 3, minus 3 of y plus 3, minus 2 of z minus 1 equal to 0. After the simplification, x minus 3, minus 3y minus 9, minus 2z plus 2. After the simplification, x minus 3y minus 2z minus 10 equal to 0. First of all, so you must understood the given the problem. Okay. And again, this problem is also very simple. 2.6.5. Find the equation of the plane which passes through the point 3, minus 3, 1. And again, it is normal to the line joining the points. Okay. So according to this point, first of all, to write the plane equation A of x minus 3, B of y plus 3, plus C of z minus 1 equal to 0. That is the first equation. Now the direction ratios of the normal to the plane of first equation is, okay, what are the direction ratios? Here that is say A, B, C. Okay, the given points DRs to write as the line joining points 3, 2, minus 1, 2, minus 1, 5. The line joining the points from the DRs. So there are 2 points is given. First of all, that is DRs means 2 minus 3, x2 minus x1, y2 minus y1, minus 1 minus 2, z2 minus z1, 5 minus of minus 1, 5 plus 1. So we are getting the values are 1, 3, minus 6. These are line joining of the normals, DRs. 1, 3, minus 6 from the given the points. So A value is 1, B value is 3, C value is minus 6. These values substituting in the first equation, that is the required plane equation. Okay. Now again, to see and practice the another problem 2.6.6. That is the intersection of any two planes. So first of all, sir, you must read and steadily given the problem. Okay. Study and steadily. That is the given the problem is the given planes are x plus y plus z equal to 6. And again 2x plus 3y plus 4z plus 5 equal to 0. There are two planes. These two planes are when the intersecting. So first plane plus lambda into second plane equal to 0. So here the problem is find the equation of the plane. So to find the plane equation, when the passing through the line of intersection of the planes, line of intersection means first plane plus lambda into second plane, S1 plus lambda S2 equal to 0. That is the formula. Okay. Now, they say that is the first equation. The given planes are, first of all, so you have to write the, when the intersection of the party means in between the planes, S1 plus lambda S2 equal to 0. To write the S1, to take the S1 plus lambda into S2 equal to 0. So since first equation is passing through the point is 1, 1, 1, replacing x, y, z by 1, 1, 1, 1 is there. After the simplification, we are getting the lambda value is 3 by 14. This value substituting in the first equation. So x plus y plus z minus 6 plus 3 by 14 of 2x plus 3y plus 4z plus 5 equal to 0. After the simplification, so 14 is LCM. 14x plus 6x, that is the 20x. So 14y plus 9y, that is 23y. 14z plus 12. 14 plus 12, that is 26z. So minus 14 into 6. What is that? 82. Okay, minus 82 plus 15. So that is minus 69 equal to 0, which is the required equation of a plane. Okay. Now, this is also one of the important problem. And 2.6.7, because a plane in the plane, each and every problem is very important to practice the 2.6.7. So, given the problem, you must study just to study and to practice this problem. Find the equation of the plane passing through the line of intersection of the planes. 2x minus y equal to 0 and 3z minus y equal to 0. These two planes are when they intersect and it is perpendicular to the plane. So first one we are taking the S1 is 2x minus y plus lambda into 3z minus y equal to 0. So after the simplification, 2x minus y of 1 plus lambda plus 3 lambda z equal to 0. Say this is the first equation. So there are two planes when they intersect, S1 plus lambda equal to S2 equal to 0. We are getting the value is, say, that is the first equation. So when the first equation, when it is perpendicular to the plane means 4x plus 5y minus 3z equal to 8. So in the first equation of the normals, perpendicular condition is, first equation is also represents after the intersection of the planes, just like that, A1 equal to 2, B1 equal to minus 1 of lambda, and C1 equal to 3 lambda. So this is also perpendicular means second in the given the plane is 4x plus 5y minus 3z equal to 8. Here A2 equal to 4, B2 equal to 5, C2 equal to minus 3. So say this is the another equation is second equation. When the first and second equation both are perpendicular, so then the normals are also perpendicular. 2 into 4 minus 1 plus lambda into 5 plus 3 lambda into minus 3 equal to 0. We are getting the lambda value, say that is 3 by 14. After the simplification, we are getting 28x minus 17y plus 9z equal to 0. So listen, students, listen carefully. Okay, 2.6.7, and again, this is also one of the important problem. 2.6.8 number of times is given in the essay as an essay question or essay problem in the university examination. Okay, that is 2.6.8. Okay. What is the part? A variable plane passes through the fixed point A, B, C. A variable plane passes through a fixed point A, B, C and meets the coordinate axis in capital A, capital B, capital C. Suppose we are taking the in the XYZ coordinates, just you have to draw the variable plane. Say this is in the XYZ axis. On the x-axis, capital A point, we must assume capital A. In the y point is capital B, y-axis is, and z-axis on the point is capital C. Okay, z-axis of the point is capital C. Okay, now after just you have to construct this. This is the variable plane of this part. This is A to B, B to C, and C to A. This is the variable plane. Just you have to draw the rectangular parallelepiped part. Okay, because the distance are different. This is the common point capital Q. Okay, variable plane is denoted by common point is capital P, and now this is also AB distance is Q and BC distance is capital P is there. Okay, now Q point fixed point is Q, so that that point is ABC. So OA distance is small x1, OB distance is y1, OC distance is z1. So this is the simplest part. So the equation of the, what is the intercept of the form? X by A, Y by B, Z by C. Here replacing ABC by x1, y1, z1, we are taking the, that is the 2.3.5 expression is there. So x-intercept A, y-intercept B, z-intercept C. So in the, just you have to, our convenience, our assumption of that, ABC is x1, y1, z1. So that is x by x1, y by y1 plus z by z1 equal to 1 is there. Okay. Now after that, since Q lies on it, Q is be the one of the surface. It is also lies on it in the variable plane. So XYZ means replacing XYZ by ABC. So A by X1 plus B by Y1 plus C by Z1 equal to 1. Okay, the plane through ABC, capital A, capital B, capital C, it is parallel to the coordinate planes. Replacing X equal to X1, that is the locus of the part, and Y equal to Y1 and Z equal to Z1 is there. So in the replacing of X1, Y1, Z1 by XYZ, that is the which meet in capital P of X1, Y1, Z1. Here the changing of the X1 to X, Y1 to Y, and Z1 to Z in equation 1. So when the equation of the locus of capital P is A by X plus B by Y plus C by Z equal to 1 is there. That is the very simplest either theorem or problem in the plane of the part. This is also one of the important students. Now these problems are also practiced your convenience part. Okay. Now this is the plane, enter the plane concept. Okay. Some other problems are also practiced here. Next one, see the next part in the unit 3 is there, because that is the end of the after the completion of unit 3, end of the first block. So when thoroughly you have to practice in the first block, easily to achieve on the pass marks. Okay. Now that is not necessary here, because after the when we have to understand the each and every one, then easily to achieve for the giving the question in the final examination. Okay. That is the unit 3. What is the unit 3? Okay. Just have to unit 3 is there. See this one. Unit 3 is bisectors of the angles between two planes and two sides of a plane. This is also one of the important concept. What is the bisectors of the angles? Okay. Now this is the one of the bisector of the, first of all, so you have to take in the this one, given the planes are bisectors of the angle between the planes ax plus by plus cz plus d equal to 0, and again a1x plus b1y plus c1z plus d1 equal to 0. We are taking the any two planes and pb any point on the any one of the plane bisecting the angles between the planes. Okay, since the perpendicular from P to the two planes are equal in magnitude. So any point, just we must assume any point capital P, that point is on the first plane. P is PB any point, perpendicular distance from point to the plane equal to modulus of ax plus by plus cz plus d by root of a square plus b square plus c square, and again mod a1x plus b1y plus c1z plus d1. That is perpendicular distance from any point to the plane. This is the another expression. Say this is the mod and this is the modulus of the ignore of the modulus. Ignore outside of the modulus, we are taking the plus or minus. Okay. Now just you have to see this one. Now the equation of two bisecting planes, the joint equation of the planes can be written as ax plus by plus cz plus d by whole square by a square plus b square plus c square, and again we are taking the square root of. So root is also cancelled. After the simplification, we are taking the on both sides whole square is there. Okay, this is the second degree equation. So after the simplification, we are taking as the positive, and second one we are taking the negative of this part. Okay. Now here the two bisecting planes given by first equation. Say this one bisects of the acute and the other one is the obtuse, angle between the given planes. So we are taking the, when it is the positive, so first plane, we are taking the first plane and the first bisecting of the simplification, either acute angle or obtuse angle. Suppose one is obtuse and second one is automatically acute of the part. So the bisectors of the bisector planes, just like that, treated as according to this one. What is that? What is that? Now, according to this expression, taking the positive, one bisecting plane equation is given, taking the negative, and second one is the second bisecting plane. And to find the first plane and the first bisecting plane, to find the angle between first plane and the first bisecting plane, automatically we can find the angle. So that angle is simply, already we know that. So angle between the two planes of bisecting plane is also nothing but the plane. Okay. So automatically one is acute and another one is obtuse of this part. Okay. Now bisecting plane, this is also just like just like that. One is bisecting plane. So this is O dash figure and this is the another one, B figure. Bisecting plane is also considered this one. This is the dotted of this part. Okay. Now figure 1A is there. 1A means now that is the what is that? Ax plus by plus cz plus d, and second one a1x b1y c1z plus d1 must have the same sign. Same sign means the denominators being both positive. When the denominators both are positive, the point x1 x y z on the locus lies on the origin, and that is the first A. And then second one is the non-origin. Non-origin means 1B is there. So 1B figure just like that. This is one of the type. Origin is also lies on the surface. Second one, now but that is also nothing but one of the plane, because the distance is also there. When the distance from the origin, distance is origin, so this is the figure. When the denominator is origin. So another one, where nothing but here the distance is given. So ax plus by plus cz plus d equal to 0, and another one a1x b1y c1z d1 equal to 0. So angle between the planes containing the origin. So it sides of the both the planes. Okay. Now here then the equation, second equation represents the plane bisecting that angle between the planes which contains the origin. Okay. Now we are taking the another one, that the other one is we are taking the minus. So it represents also plane bisecting the other angle between the given planes. One is the positive and second one is the negative of this part. Now see this one, this problem is very important of the discussion or discussed apart planes through the planes of the bisecting planes. So this problem is very important in the final examination, students. Listen carefully. Okay. Find the equations of the plane bisecting the angles between the planes. So bisecting angles, how to, first of all, we must find the bisecting angle, bisecting planes. A1x, B1y, C1z equal to D1 and A2x, B2y, C2z equal to D2. Yes. Okay. Now, there are two planes is given and according to the two planes, first of all, so you must write the bisecting part. So, 3x minus A1x, B1y, C1z plus D1 equal to 0 means A1x from the point is taken modulus of A1x, B1y, C1z plus D1 by root of A1 square, B1 square, C1 square equal to again modulus mod A2x, B2y, C2z plus D2 by root of A2 square, B2 square, C2 square. Simply, first of all, after the remove of the modulus, we are taking the plus or minus. What is that? Plus or minus is there. Plus or minus. Okay, here 3x minus 4y plus 5z minus 3 by root of 3 square plus minus 4 whole square plus 5 whole square. That is A1 square, B1 square, C1 square. And again that equals to after the remove of the modulus, we are taking the plus or minus 5x plus 3y minus 4z minus 9 by root of 5 square plus 3 square plus minus 4 whole square. That is the drs of the second plane. Okay. Now, here after the simplification, first of all, 3x minus 4y plus 5z minus 3 by after the simplification root 50 equal to plus or minus 5x plus 3y minus 4z minus 9 by after the simplification this is also root 50. So denominators are same. When the denominators are same here. So we are taking the, so after the cancellation of the denominators, 3x minus 4y plus 5z minus 3 equal to plus or minus 5x plus 3y minus 4z minus 9. First of all, so you are taking the positive. Positive means after the simplification, first of all, so you are taking the positive value. So after the simplification, 3x equal to plus 5x. So enter this value converting into this side, 5x minus 3x is 2x, 3y plus 4y is 7y, minus 4z and minus 5z means minus 9z, minus 9z, minus 9 and plus 3, that is minus 6 equal to 0. Say this is the first bisecting plane. Second bisecting plane is, we are taking the negative expression minus of 5x plus minus of 5x plus 3y minus 4z minus 9. After the simplification, we are getting the another second bisecting plane, 8x minus y plus z minus 12 equal to 0. Say there are two bisecting planes, third equation and fourth equation. So theta is be the angle between the planes, third equation and second equation. Okay. Okay, that is the, then we have cos theta equal to, second equation means second plane, 5x plus 3y minus 4z minus 9. Okay. So that is the third equation and second equation. In between theta be the angle between the planes. Cos theta equal to, and according to the normals, second plane and the first bisecting plane, 2 into 5 or first bisecting plane and the second plane. In between, to find the angle between those are cos theta equal to A1, A2, B1, B2, C1, C2 according to their normals. We are getting the 67 by 5 to root 68. So it is the one of the note, angle between a bisecting plane and one of the given planes is not greater than 90 degrees. Okay. So 67, this is also greater than 1 is there. Then we have taken cos theta be the positive. Okay. When the positive tan theta according to the cos theta, then we must find the value of cos theta. And first of all, sin theta is there. And according to the sin theta, then automatically easily to find tan theta value. So here tan theta value, here theta is less than 45. Less than 45 means in between, theta is the half the angle between the given the planes. Then automatically 2x plus 7y minus 9z minus 6 equal to 0 bisects the angle between the planes. So 2 theta is less than, because multiplying on both sides, 2 theta is less than 2 into 45 is 90 degrees. So that is the less than 90 degrees means acute angle. So the first bisecting plane is the acute angle. Similarly, theta be the angle between the planes. Fourth equation means second bisecting plane and second equation. Okay. And cos theta equal to 5 into 8. Okay. Second, 5 into 8. This is the fourth equation. First means 3x minus 4y plus 5z minus 3 equal to 0. In the second equation is 5x. So according to this one, that is, see this one, cos theta equal to 5 into 8 plus 3 into minus 1 and plus minus 4 into 1. So again, that value cos theta is root 33 by 10 is there. So according to the cos theta, to find the sin theta value, root of 1 minus cos square theta, and that value is, and again, sin theta and from sin theta and cos theta values to find the tan theta value. So that is greater than 1. So theta is greater than 45. So when it is greater than 45, so that is the obtuse angle. When the theta value is greater than 45, that is called obtuse. Okay. Then automatically easily to see and practice the 3.2.2 same problem. Okay. First of all, to find the bisecting planes. And according to the bisecting planes, first equation and third equation in between, theta is the angle. And again, third equation means it is bisects the acute angle. Okay. Acute angle means, and therefore it is the origin lies in the acute angle. Okay. So this is also one of the important part. That is the one of the practice problem from the bisecting planes. Now this is the two sides of a plane. What is the two sides? A point, B point is given. Those points lies on the same side or opposite sides of the planes. This is also one of the important problem. There are 2 points is given and the plane is given. And when these 2 points is substituting on the given the plane, okay, when it is the same side or opposite side, how to find the same side and opposite side? So first point is substituting in the plane a by ax1, by1, cz1, and second point is also given or the same side or different signs. How to get this one? Now AB meets the given in the plane in a point capital P, P divides AB. So those points are, say, we are saying A point, B point in the ratio lambda is to 1. So already the coordinates of P means as an internally or externally. Lambda x2 plus x1 by lambda plus 1, lambda y2 plus lambda y1 by lambda plus 1. So that point, coordinates of the point is substituting given the plane, we are getting this is lambda value is negative. So when the lambda value is negative or positive, according as the first plane and second plane are of either same or different signs. Okay. The negative means positive means same sign and the negative means that is the different signs are there. Okay. Now this is according to the above concept. We have to see this one. 3.3.1 problem is there. Show that the origin is given and another point is kept A point. It lie on the opposite sides of the plane. So given the first of all, you must write the given the plane. Origin means x plus 3y minus 5z. So x value, y value, z value is 0. We are substituting. Now here the 7. 7 means greater than 0. So first point is substituting given the plane that is greater than 0. And again another point, A point is also substituting given the plane. So that value is minus 18 means that is less than 0. So first point is lie on the opposite side. So O point, the given points O and A, those points are, one is greater than and second one is less than. So greater than and less than means that is the opposite signs. Both are less than 0 means that is the same sign. Both are greater than 0 means that is the same sign. But it here, one is greater than 0. First point is substituting given the plane greater than 0. And second point is substituting in the given the plane that is less than 0. So both are opposite signs, greater than and less than. When it is both are less than, both are greater than, that is the same sign. Just like that, this is also same manner. A and B points are given. So one of the plane is given. Those points are on the same side. So A point substituting given this plane, so that is less than 0. B point is also substituting given the plane, that is also less than 0. So both are less than 0 means that is the same side on the given the plane. Now these are all this is also one of the practice part. Okay, 2 and 3. Very simple. What is the joint equation? Listen carefully. What is the joint equation? There are two planes are given. Consider the equation first plane into second plane equal to 0. That is the joining of this part. When the first plane and the second plane equal to the product of any two planes, when it is an equivalent to 0. So any point is on the first third equation x1, y1, z1. ax1 plus by1 plus cz1 plus d equal to 0. Okay. And again, that implies here the first one and second one is a1x2 plus a1x1, same point. And again, that is also x1, y1, z1 is also substituting in the third equation. We are getting is a1x1 plus b by, when the first one is 0, then automatically second one is also equating to same point lies on the second equation. So that is the joint equation. Okay. Now same point lies on the third equation. So we are getting ax1, by1, cz1 plus d equal to 0. And again a1x1 plus b1y1 plus c1z1 plus d1 equal to 0. So we are getting the point lies on the plane first equation or the plane second equation. So that is the point lies either on the plane first equation or on the plane second equation. If and only if first plane plus second plane equal to 0. That is the joint, means a combined equation to the two planes. Okay. Students, listen carefully. This, according to the joint plane equation, this problem is very important in the final examination. There is no doubt. If ax square plus by square plus cz square plus 2fyz plus 2gzx plus 2hxy plus 2ux, 2vy, 2wz plus d equal to 0. This equation represents a pair of planes from the joint, means combined plane equations. We are getting the equation pair of planes from the joint plane equations. That is ax square, by square, cz square, 2fyz, 2gzx plus 2hxy plus 2ux, 2vy, 2wz plus d equal to 0. This equation represents a pair of planes. And again, when the u, v, w is 0, we are getting the remaining equation ax square, by square, cz square, 2fyz, 2gzx, 2hxy equal to 0. This also represents a pair of planes when it is passing through the origin. Pair of planes parallel to the passing through the origin. So the parallel to passing through the origin means we are taking the given this equation ax square, by square, cz square, 2fyz, 2gzx, 2hxy. This is also one of the theorem. Means first of all, so you have to write the represents a pair of planes. Okay. Pair of two planes means first plane represents in the replacing a, b, c by normals are L1, M1, N1 in the replacing of by first plane equation. And again, we are taking the L2, M2, N2. We are taking the second normals. We are taking on the plane equation L2x plus M2y plus N2z plus D2 equal to 0. There are two planes. First of all, comparing it with to write as the ax square, by square. Entire that representing a pair of planes is also equivalent to combined the plane equations. What is that? First equation and second equation. L1x, M1y, N1z plus D1 of L2x plus M2y plus N2z plus D2. Comparing the coefficients of x square on both sides. Here, just you have to see and observe this one. What is that? Here x into x square. Coefficients is L1 and L2. So x square coefficient is L1, L2. So here x in the left side of the x square coefficient is A. So A equal to L1, L2, and again to write as the y square coefficient is M1, M2, and here at left side that value is an equivalent to B. Z square coefficient is C equal to N1, N2, and again M1, N2 plus M2, N1 of the coefficient. M1, N2, M means the YZ coefficient. M1, M2 plus, because first of all, that is the simple matter, X, Y, Z, F, G, H. So YZ coefficient is, that is F. So that is 2F. And G is the second one. So XZ coefficient is 2G equal to L1, N2 plus L2, N1. And XY coefficient is H. That is 2H equal to on left side. To XY coefficient of at left side is 2H equal to, here the XY coefficient of the combined joint plane equation, that is L1, M2 plus L2, M1, that is the XY coefficient. So that value is an equivalent at left side to H. So L1x equation of the plane parallel to first equation and passing through the origin is L1x M1 by N1Z equal to 0. And again second equation is also plane parallel to the second equation passing through the origin is L2x plus M2y plus N2Z equal to 0. So the joint equation is the third and the fourth equation combined, that is also equal to 0. So L1 L2 x square, M1 M2 y square, N1 N2 z square, and again YZ coefficient is M1 N2 plus M2 N1, and ZX coefficient is L1 L2 plus L2 N1, and again XY coefficient is L1 M2 plus L2 M1. And comparing the on both sides, replacing of that value, x square means A, y square means B, Z square means C. So AX square plus BY square plus CZ square, and this value is an equivalent to 2F of M1 N2 plus M2 N1. This is ZX coefficient is that value is an equivalent to 2G. So this is L1 L2 plus L2 N1 is 2G ZX. This value is 2H of XY equal to 0. So this is the second degree homogeneous equation. So derive the second degree homogeneous equation means that the entire this is the 3.4.1. Now here the some other conditions of the represents a pair of planes passing through the origin if and only if what is that? ABC plus 2FGH. This equation represents a pair of planes passing through the origin. We are taking this one if and only if ABC plus 2FGH minus AF square minus BG square minus CH square equal to 0. So comparing it with F square is greater than, because FGH ABC. So F is in the same column. So A is absent. F square is greater than BC. G square is greater than AC. And H square is greater than AB. First of all, just you have to rough part is there. Taking A, B, C, F, G, H. F is also in terms of BC, and G is also in terms of AC, and H is also in terms of AB is there. First of all, the given equation, just you have to write the given equation. It represents the pair of, represents the two planes. What are the two planes? L1x, M1y, N1z equal to 0. L2x, M2y, N2z equal to 0. And comparing it with the passing through the origin of a represents a pair of planes, that is an equivalent to combined the means a joint plane equations. Comparing the coefficients to write as the L1 L2 0, M1 M2 0, N1 N2 0 crossed L2 M2 N2, L1 M1 N1 0 0 0 is there. Okay. Okay. And after the simplification, we are getting entered that values of the determinant 8 mod AHG H, because all the values substituting in this after the simplification, we are getting this is mod AHG HBF GFC equal to 0. Okay. Now after the determinant of this part, ABC plus 2FGH minus AF square minus BG square minus CH square equal to 0. And again, that is the necessary condition. So condition is F square minus BC means F value substituting and B value, C value substituting. We are getting the that value is greater than or equal to 0 because f square is greater than or equal to bc. G square, similarly we can prove that g square is greater than or equal to ac and h square is greater than or equal to ab. So that is the necessary part, and converse is also in the same manner. Okay, this theorem is also very important. According to this theorem, and to find the angle between the pair of planes, what is the angle? Cos theta equal to plus or minus a plus b plus c by square root of a plus b plus c whole square plus 4 of f square plus g square plus h square minus ab minus bc minus ca. This is the angle between the pair of planes. Okay, now this is the angle between the pair of planes passing through the horizon condition is this is, then the angle is cos theta is plus or minus the coefficient of x square plus y square plus z square coefficients by root of coefficient of x square y square z square and whole square plus 4 of f square plus g square plus h square minus ab minus bc minus ca. So the theorem is also very important, and according to the cos theta, then we must find the sin theta value is there, and according to tan theta equal to, what is the tan theta value? Okay, tan theta equal to 2 root of f square plus g square plus h square minus ab minus bc minus ca by a plus b plus c. That is the tan theta value of angle between the two planes, pair of planes. So when the planes are perpendicular, theta is pi by 2 cos theta equal to 0. Hence the condition is a plus b plus c equal to 0. And the planes are coincident. Coincident means identical. Theta is 0 degrees. So cos 0 is 1. So we are getting the a plus, what is the condition? F square equal to bc, g square equal to c, and h square equal to ab. So that is also simple. The drs of the line of intersection of the planes represented by, what are the drs? Square root of f square minus bc, root of g square minus ac or ca, root of h square minus ab. This is also one of the important according to the angle between the pair of planes. Okay, that is also very simple. Just you have to see and practice here. The drs of the line of intersection. Okay, now this problem is very important. Just you have to refer in the previous papers. That problem in the above theorems, according to the above theorems, that is 3.4.4. Show that the equation 12x square minus 2y square minus 6z square minus 2xy plus 7yz plus 6zx equal to 0. This equation represents a pair of planes. First of all, and according to the find the angle between them. First of all, you have to write the given the equation and comparing it with the general equation of the pair of planes. This is also just like that, this is formed represents a pair of planes passing through the horizon, because this is the xy, yz, zx terms are there, but not remaining part. So a value is 12, b value is minus 2, c value is minus 6, and this is the xy coefficient. Xy coefficient is h. Okay. So 2h equal to minus 2, h equal to minus 1. This is yz. Yz means this is the f coefficient. So 2f equal to 7, f equal to 7 by 2. This is zx coefficient, that is g. So 2g equal to 6, g equal to 3 is there. So what is the equation? So represent a pair of planes equation is abc plus 2fgh minus af square minus bg square minus ch square equal to 0. So after the substitution of given the values, that is an equivalent to 0. Okay, and again f square is greater than bc. So f value substituting, that is 49 by 4, bc value is 12. So 49 by 4 means approximately 12 point something is there. So this value is greater than bc is there. So f square is greater than bc verified. And similarly, g square value is also according to the above values. And ca value is also there. Both values are observed. 9 is greater than minus 72. So g square is greater than ca and h square is greater than ab on the 3 coordinate planes. Okay, ax equal to LA, ay equal to m dot a, az equal to n dot a. So LM and be the DCs of the normal to the plane of the area capital A, and L is the, what is the orthogonal projection? So L be the cosine of the angle between the YZ plane. M is the cosine of the angle XZ plane. N be the cosine of the angle between XY plane. So that the here to write as the AX, AY, AZ. So replacing of that values, we are getting the A equal to square root of AX square, AY square, AZ square. So this is one of the problem. Find the area of the angle whose vertices of the points. There are 2 points is given, 3 points is given. How to find the area of the angle? First of all, AX, AY, AZ. That is the A is the required area, be the triangle. So AX, AY, AZ is the areas of the projections of the area capital A on XY, YZ, ZX planes. The vertices of the projection, the triangle on the XY plane. XY plane means Z equal to 0. So according to the points 1, 2, so this is 0. Minus 2, 1, this is Z coordinate is 0. 3, 4 is taken in the third vertices, Z is 0. So we are taking the 3 points according to the AX area of the AZ. AZ means to write as the Z coordinate is 0. So 1 by 2 mod. What is the formula? 1 by 2 mod, because 1 by 2 into 1 by 2 into 1 by 2, that is the 1 by 8 is there. So each and every, we can deviate on the coordinate axis for the X, Y, Z on axis. So particularly here the Z axis, we are taking the 1 by 2 mod to X1, Y1, Z1, X2, Y2, Z2, X3, Y3, Z3. So 1, 2, 1, 1, 2, and again minus 2, 1, and this is 3, 4. And the constant is 1, 1, 1 is there. This is the constant of the part. We are taking the 1, 1, 1. So that is the third column. So again, that after the simplification, we are getting the minus 2. And again, some vertices of the projection of the triangle on YZ. YZ means X equal to 0 for the given the points. So given the points, we are taking the X coordinate is 0. Remaining values are same. AX equal to 1 by 2 of replacing of X coordinates, we are taking the 1, 1, 1. So 2, 3, 1 minus 4, 4 minus 2. After the simplification, 19 by 2. And in the same manner, AY. AY is also Y coordinate is 0. Okay. After the simplification, 1, 3 minus 2 minus 4, 3 minus 2. And again, third coordinate is third column is 1, 1, 1. After the simplification, 29 by 2. Find finally the area of the triangle A equal to root of AX square plus AY square plus AZ square. We are getting the value is root 12, 18 by 2. That is the very simplest part. Okay. That's enough, students. This is the volume of a area is the common part in between the plane of the points. But it is a volume of a tetrahedron. What is the volume of the tetrahedron? There are 3 points. Here ABC be the variable plane, and this is AL is perpendicular to the BC. So L be the foot of the perpendicular from A to the plane BCD. So this is the BCD part. This is the A is perpendicular to the BCD. So AL of the point is small p. So X1, Y1, Z1, X2, tetrahedron means there are 4 points given. A, B, C, D from the vertices of a tetrahedron. So according to the tetrahedron part, then the formula is capital V equal to 1 by 3 delta. That is the 1 by 3 modulus P into delta. Okay. Mod P into delta, it stands for absolute of PA. The equation of the plane BCD is XYZ1, X1, Y1, Z1, 1 according to the BCD points. X absent of X1, Y1, Z1 point without capital A. In terms of XYZ, X2, Y2, Z2, X3, Y3, Z3, X4, Y4, Z4, and the constant of the part is 1. So the entire that equal to 0. So X of modulus of Y2, Z2, 1, Y3, Z3, 1, Y4, Z4, 1 minus Y of X2, Z2, 1, X3, Z3, 1, X4, Z4, 1 plus Z of means X2, Y2, okay, plus Z of means X2, Y2, X3, Y3, X4, Y4. Constant is 1. Plus minus of X2, Y2, Z2, X3, Y3, Z3, X4, Y4, Z4 equal to 0. After the simplification, P equal to the modulus x1, y1, z1, x2, y2, z2, x3, y3, z3, x4, y4, z4. So here delta x value of the volume of the tetrahedron area. First of all, you have to find the area delta x, delta y, delta z plus or minus 1 by 2 mod y2, z2, 1, y3, z3, 1 absent of x2, y2, z2. And again delta y, it is also y is absent of the above part. We are given the delta y. Delta z means z coordinates are absent. Finally, delta square equal to delta x square. Already you have to find the area. So the denominator of P is equal to 4 of delta x square, delta y square, delta z square whole power 1 by 2 equal to 2 delta. So 2P delta equal to, that is the concept. So finally volume equal to 1 by 3 into small p into 1 by 2P of, to write as the given this one. Finally we are getting the expression is 1 by 6, P is cancelled. 1 by 6 mod x1, y1, z1, 1, x2, y2, z2, 1, x3, y3, z3, 1, x4, y4, z4, 1. This is the volume of the tetrahedron. ORR in the terms of absolute value of 1 by 6 of B minus A cross C minus A dot of dot D minus A. So that is also another part. So here B minus A means in between AB points. We are getting the B bar minus A bar according to the vertices. C minus means through the AC points. AD means through the D minus A. So this is also another model. Okay. So problem is given, volume of the tetrahedron, there are 4 points is given. Now those values are substituting here. After the row operation, we are applying the row operation R2 minus R1, R3 minus R1, R4 minus R1 in the matrix representation. We are getting the value is, after the applying row operation is there, we are getting the simplest part. That is the 2 by 2 part is there, because the remaining third column of 2 elements is 0. We are taking the 16 minus 2, 2 and 2 is there. So this is the determinant of this part. 32 plus 4 is 36. 1 by 6 into 36 means 6. So that is the volume of the tetrahedron. Students, this is the end of this unit. So that's enough. This is the our convenience, especially your convenience. Enter the first block is completed. Especially only first block, if you have to see and refer, clean observation, each and every one. So easily to get the pass and good marks is there. So second block, so tomorrow we will meet the next 2 classes. Very important session. Don't miss it. Remaining 2 classes are very important. That is the shortest distance and image problems and sphere problems. Okay. Now, okay. Anyhow, thank you. One and all, already time is over. If you have any doubt, to contact us and personally on the previous class, already I told my mobile number and again WhatsApp contact. Okay. Anyhow, thank you one and all. Wish you all the best and wish you good luck. Any doubts? Please stay on the line. Thank you. Tomorrow, next class, we will meet the next class. Thank you.